Hi there, welcome to this tutorial on being able to integrate a function using substitution, sometimes known as U substitution. I'm going to go through two examples here. The second one obviously slightly more difficult than the first one, but I'm going to try and show you a really easy method that we can use to be able to do this substitution in order to integrate this function here. So what we're going to do to start with, we're going to substitute part of this function and call it U. And the part of the function I'm going to substitute is this 2 plus x cubed. This is the part in the brackets. Most of the time, take the part in the brackets, if there is something in the brackets, and call that u. So we get 2 plus x cubed. Now, I'm now going to do two things. First of all, I'm going to differentiate this part here, this u. Then I'm going to replace within my function the 2 plus x cubed with u. So I'm going to differentiate this first, so I'm going to find du dx. 2 disappears, x cubed differentiates to 3x squared. Now what I'm going to do is I'm going to try and replace my 2 plus x cubed with u, but I'm also going to try and replace this dx here. So what I'm going to do is I'm going to excuse me, I'm going to rearrange this function so that I've got dx as the subject. So I'm going to take this dx up to here. So this gives me du equals 3x squared dx. Now what I'm going to do is I'm going to take the 3x over. So I'm going to end up with du over 3x squared equals dx. I've now made dx the subject. I'm going to write this slightly differently. I'm going to change this du over 3x squared and I'm going to write it as 1 over 3x squared du. Now what I'm going to do is I'm going to replace this 2 plus x cubed with u. So I'm left now with the integral of 3x squared. The part in the brackets now becomes u, so that's u squared. And my dx now is 1 over 3x squared with respect to u. I've still got x's in this function here. You can see this 3x squared, 3x squared. But if we look, these will multiply together. 3x squared times 1 over 3x squared just gives me 3x squared over 3x squared, which simplifies obviously to 1. So I'm left with the integral of u squared with respect to u, to du. Very simple integral to complete. So what I'm going to do now is I'm going to integrate this, and that's going to give me u to the 3 over 3. Remember, power goes up by 1, divided by the power. The du now has disappeared when we integrate. So what I'm now left with is u cubed over 3. I could write this as 1/3 u cubed. And all that remains for me to do now is to substitute back my expression for u in this expression here. So I get 1/3 my u. I'm going to substitute back with what it was at the start, which is 2 plus x cubed. And then obviously I need to add the constant of integration c. Okay, for example 2, I'm going to use the same method. It's got one more step to it, so it's a little bit more complicated, but I'm going to start off exactly the same way. I'm going to start off, I'm going to make my 2x minus 1. That's going to be my u. So I'm going to write down u equals 2x minus 1. I'm now going to differentiate this with respect to x to find du dx, which is 2. And then I'm going to rearrange this to make dx the subject. So taking the dx up, timesing it by the 2, and then dividing the du by the 2, I end up with dx equals 1/2 of du. Now I can replace my u and my 2x minus 1 with u and my dx with half du. I've still got this x here, but then I'm replacing this with u, and then I'm timesing it by half du. Now what you'll notice in this situation is I've still got the x here, and u's. I can't integrate when I've got x and u. So what I'm going to have to do this time is I'm going to have to go back to my original substitution here and rearrange this. So if I take the 1 over and divide by 2, I end up with x equals u plus 1 divided by 2. Now I can substitute this back into the function and substitute u plus 1 over 2 in place of x. So I'm going to write the half at the front here. So I've got half u plus 1 over 2 multiplied by u to the power of 4 du. Now I can simplify this a little bit. So what I'm going to do now is I'm just going to multiply all this by a half. So I'm going to end up now with 1/4 u plus 1/4, and then I'm going to times that by u to the 4. Once I've multiplied that out, I'm going to end up, in actual fact, I'm just going to take this 1/4 out here. So I've got 1/4, and then I've got u plus 1, just factoring out the quarter there, u to the 4, still with respect to u. I can now take out this constant, this 1/4. So I'm going to take this out of the integral, and that if I multiply out these brackets now, I'm going to have to integrate u to the 5 plus u to the 4 with respect to u. So if I integrate this, I'll just go up here, I'm going to end up with 1/4. Integrating this function, I'm going to have 1/6 u to the 6. Remember, just raise the power by 1 and divide by that. So the second part, raise the power, I get, and divide by 5, I get 1/5 u to the 5. If I now multiply all this by 1/4, I'm going to end up with 1 over 24 u to the 6 plus 1 over 20 u to the 5. And to finish off, I can actually add these together. I've got a common denominator here of 120. So if I write my common denominator 120, I'm going to multiply this one here by 5. So I've got 5 u to the 6. And multiply this one by 6, I get 6 u to the 5. I can factor that out. So I can take u to the 5 out. So I get u to the 5. U to the 5, and then inside of this, open up the brackets, I've got 5u plus 6 over 120. All I have to do now is replace the u's with the 2x minus 1. So I'm starting off here, I've got 2x minus 1 to the power of 5, and then 5 times 2x minus 1 plus 6 over 120, which then simplifies to give me 2x minus 1 to the 5, and then this is 10x minus 5 plus it is plus 1 all over 120. Okay, hope that helped. Thanks for watching, and I'll see you again soon. Bye now.